All right, pre-calc class, we are going to go over our 2-1, 2-4 practice test. Again, on your test, you will be given all of these formulas. You don't need to memorize them, just know how to use each of them. We have two options for our equation of a line. We will eventually put it into y equals mx plus b, but you can either start with that or start with this other one. I prefer this formula, and you'll see that when I do the problems. We all need to use the slope formula. Got to start out with slope when you're finding the equation of a line. And then we get into our quadratics. So we have vertex form of a quadratic. And then we have h, our formula for h, the negative b over 2a. Again, just want to remind you about that negative out front. Oftentimes it blends in with our fraction bar or something else happens and we just miss that negative. So just be careful of that one because that's a common mistake. And then for k, we have c minus ah squared. Order of operations, you got to make sure you do your h squared first. But if you plug this whole thing into your calculator, it will give you the correct answer. Then we go on to our two equations that we will use for our projectile motion, free fall motion. Negative 16 t squared plus v sub 0 is your initial velocity. It's the same v sub 0 over here for initial velocity. And then s sub 0 is your initial height. So how high is the object starting whenever the problem is beginning? All right, so let's go ahead and jump into these problems. We are going to be starting off with two problems on just what is a polynomial. So for this first one, like we talked about before, the problem here is the exponent. So this one is not polynomial, and we can abbreviate that, just not poly. And we want to just say, why is it not polynomial? Because we have a negative exponent. Okay, that's all the further that we need to go with that. I don't need some elaborate explanation. That's good enough. No negatives and also no fractional exponents in polynomials. So that's what you're looking for. For number two, this one is a polynomial function. So if it is a polynomial function, we will go ahead and label the degree and the leading coefficient, which I'll just abbreviate that LC for leading coefficient. So the degree is your highest power, which our highest power here is a 5. And then the leading coefficient is just the number out front of that term, so that will be a 3. Okay, so again, starting off with some basic problems here, nothing too elaborate happening in those two. Then we move on to our two problems that we had for linear functions. And again, like I had mentioned before, this is saying that we have the point 2,4 and we have the point 5,1. Okay, so it's just a different form of giving that point to you. It's given to you in a function notation instead of just a straight up point like you've always been given. So we want to just go ahead and write that as a point just to refresh our memory and put us back into stuff that we've seen a lot in Algebra 1. So once we have this, now we're going to go ahead and get into our slope formula. We always got to start with slope. So I'll write it down. You don't have to write down the formula, but I will put this here so you can see which one we're using. And then what I always like to do is replace all of my variables with parentheses so I don't miss any of those double negatives that may or may not happen. So y2 is 1, y1 is 4, x2 is going to give me a 5, and x1 is a 2. So we go through and simplify. 1 minus 4 is a negative 3. 5 minus 2 is a positive 3. And when we simplify that, we end up with a negative 1. So now, like I said, I prefer to use the y equals mx plus b. I just prefer to use this and start off with this. Now, you can pick and choose whichever one of these points you want to use. It doesn't matter. Just pick one. I'll just use that second one. So in that second one, y is 1. M we just solved for. That's a negative 1. X is 5. And then we are trying to solve this for b. So 1 is equal to negative 5 plus b. And we're going to move this guy over here by adding 5. We end up with 6 equals b. So I have b and I have m. I'm ready to write my equation of a line. Y equals mx plus b. So negative 1x plus 6. All right, so that is our final answer there. You don't need to have the 1 there. You could just have a negative x plus 6, but I'm fine either way. All right, next one, same type of problem. We're just going to go ahead and go through this one. And again, this is the point negative 7, negative 6. and we have the point 1, -2. All right, so again, just like the last one, we're going to start off with our slope formula. y2 minus y1 over x2 minus x1. So here we go. y2, before I plug these in, let's replace those with parentheses. So y2 is -2, and y1 is a -6. x2 is 1, and x2 is -7. So we have a double negative here and a double negative here that we got to keep track of, okay? So -2 plus 6, that's going to give us a 4. And 1 plus 7 is 8, so this reduces to 1/2. Make sure you reduce everything. All right, now we will take this and go to my y equals mx plus b. Pick a point. I'm going to use the first point this time. Again, it doesn't matter. Some of you may say, well, I'm going to use the 1, -2 because it's smaller numbers, and that's fine. You can use that. I'm just going to mix it up here. So in this problem, y is -6. M, the slope I just solved for, is 1/2. X is a -7 plus b. So you can see here that we're going to end up with some fractions, but just use your calculator and make sure that you get these numbers, okay? 1/2 times 7 is a -7 over 2 plus b. And then I'm going to add 7 over 2 to the other side, plus 7 over 2. And what we're going to end up with here is a -6 plus 7 over 2 is going to be a -5 over 2. Okay, so that's B. All right, so final answer. Let's put this into our y equals mx plus b form. Y equals m is 1/2. X, b is a -5 over 2. And that is your final answer. All right, so 2 problems from Algebra 1 type stuff with a different function notation, just writing your equation of a line. Then we move on to our Algebra 2 quadratic parabola problems here, okay? So we're going to list 2 things. We're going to list the vertex and the axis of symmetry, and then we're going to graph. All right, so we want to make sure that we have all of our pieces here, okay? So the vertex, okay, remember your vertex is opposite of this number, same as this number. So 3, -4, that's your vertex. Your axis of symmetry is always x equals whatever your h coordinate is, so in this case it's 3. All right, so we want to label those, and then we're going to put it on the graph. So I have 3, 1, 2, 3, -4, 1, 2, 3, 4. Put a point. There's your vertex at 3, -4. And then this number right here tells us what else we need to know. So the negative means it's going to be open down, and the 2 means it's going to be a little bit more narrow. So what we're going to do is just, again, a rough sketch. That's all you need to do for that, okay? So vertex, 3, -4. Again, opposite this number, same as this number. Axis of symmetry is always x equals your h coordinate. Put it on the graph. Number 6, we got to go back to our formulas because we want to, first of all, we want to put this into our f of x is equal to a x minus h squared plus k. So we're going to put this into vertex form first, okay? Now, as I go through and figure out these numbers, I will erase them and fill them in. So I already know that a, okay, a is 1. That's the number out front here. That's a 1. So let's go on to h. Excuse me. H is negative b over 2a. So negative b is a -4 divided by 2 times a is 1. So again, you can plug this into your calculator. Just when you do that, make sure you have extra parentheses around here. Otherwise, it'll give you the wrong answer. All right, so this is, we got a double negative. 4 divided by 2 gives me 2. All right, so I'm going to fill that in here. All right, that is a 2. And the last one, k, we have to use h because the formula for k is c minus ah squared. So we'll fill these numbers in. C is 6 minus a is 1. H we just solved for is 2 squared. Again, plug that in your calculator exactly the way it looks there with parentheses and everything, and you will get a 2. So now I know that k is 2. So we'll fill that in up here. And I have my final answer, and I'm ready to go to my vertex and axis of symmetry. So the vertex here is opposite this, same as this. So 2, 2. There's your vertex. Axis of symmetry, x equals this number here, which is 2. Put it on the graph. 2, 2. We're going right 2, 1, 2, up 2, 1, 2. Put a point. This number right here or right here, same thing, tells us what we need to know about whether it's facing up or down and whether it's, we'll call it a normal width or if it's wider or narrower. But it's a positive one, so it's opening up. And since it's a 1, that means we'll call it a normal width. So just kind of draw something at a normal width, and that's all you need to do there. On to number 7. Now again, I know this is probably going to be one of the more challenging problems on the quiz. But again, you have formulas, so let's just follow through our formulas and just make sure that we're plugging numbers in correctly. So we want to find an equation that models the height of the rock t seconds after it's thrown upward. Person standing, let's start off with this. A person standing near the edge of a cliff that's 128 feet above the lake. That is our initial height, s sub 0. Throws a rock upward with an initial speed, that's the same thing as initial velocity, 32 feet per second, that's v sub 0. So we're going to start this, s of t equals negative 16t squared plus v sub 0 times t plus s sub 0. So let's fill them in. We know that v sub 0 is 32. We were given that, right? The initial velocity is 32. We also know that our initial height, the initial height was 128 feet. Okay, that's all we have to do for part A. For part B, we do need to take this a little bit further, and we're going to put this into vertex form. Okay, find the vertex. We're going to put it in vertex form. So I'll do that here in this one. So I need to find h. Well, let's start off with s of t is equal to a t or x. You could put an x in there, that's fine. T minus h squared plus k. Okay, technically in this problem we're using t's instead of x's, but if you put an x there, I'm not going to mark it wrong. That's acceptable. I'll understand you know how to do the problem, and variables not super important. All right, so first up, we know that a is negative 16. Okay, we're given that. Here's a, here's b, here's c. When I find h, again, I'm going back to my formulas that I just did in that last problem. So negative b over 2a. So we have a negative, b is 32, divided by 2 times a is negative 16. Again, use your calculator and you should get a 1 here. So h is 1. Remember, these numbers should be a positive, okay? We should have a positive because this is actually referring to time. So you can't have, if you ended up with like a negative 3, you can't have negative 3 seconds. That doesn't make sense. So that should be a positive number there. And the last thing, k, is c minus ah squared. So c is 128. A is negative 16. H is 1 squared. Plug it in your calculator, you should get 144. 144. So that is our k value. And again, it should be a positive because this thing is being launched up in the air. The highest height that it will be should be a positive number. Now, once we do that, let me separate this here. We can now label the vertex. Okay, the vertex is 1, 144. 1, 144. And once you do that, you've actually already done the work for C and D. So let's go through those two. What is the maximum height? Well, the maximum height is your k value, so that was 144 feet. How many seconds is your t value, your h value of your vertex? So we just want to say something like it will take 1 second to reach 144 feet. Just something like that. Again, nothing major. I don't need a whole paragraph. Just simple sentence like that is fine. The last one, we're asked about the velocity. So this is saying, what is the velocity of the rock when it hits the lake? So our velocity formula is negative 32t plus the initial velocity. Sorry, not initial height, initial velocity. The initial velocity. So we know that the initial velocity from the original problem, we were given the initial velocity was 32. But now the question is, what is the velocity when the rock hits the lake? So we have to first of all find out how long will it take for the rock to hit the lake, and then we need to figure out what's the velocity when that happens. So just to give you a little picture of what's happening here, somebody's up here on a cliff, 100 and whatever feet in the air, launches the rock. This is the lake, so this is what we're looking for. So what we're actually trying to find here to start off with is, where is our original function equal to 0? Okay, where is the original function equal to 0? So our original function, let me switch my pen over here. Our original function was s of t negative 16 t minus 1 squared plus 144. And we want to know, where is this equal to 0? So I'm just going to set that equal to 0 and then solve it from here, okay? So again, we've done these before, but let's just run through this one here. So subtract 144, and I'll show you another way to do this when I'm done with this, but I think this is probably the way most of us did it. So those are gone. We get a negative 144 is equal to negative 16t minus 1 squared. Divide both sides by negative 16. And we'll end up with a 9 equals t minus 1 squared. Take a square root, and again, normally with this we would have a plus or minus, but remember we're talking about time, so we don't need a plus or minus here, it's just going to be the positive. So 3 is equal to t minus 1, and then we will add 1 to both sides, add 1. So 4. So that this t equals 4, that tells us that it took 4 seconds for the rock to hit the lake. Okay, so that's what we'll plug in here. We want to find, back up here, we want to find v of 4, so we do negative 32 times 4 plus 32. And again, plug that into your calculator, and you will get a negative 96 feet per second, okay? And again, that problem, there's 2 parts to it. Even though it's only one question, there's actually 2 parts to it, because you need to figure out the time on your initial problem, or from your initial function, and then take that time and plug it in. Okay? Now I will show you, excuse me, I will show you another way to do this. This part over here. So let me erase this part over here. And I'll show you another way to get this, other than like setting it equal to 0 like I did here. Well, we're still setting it equal to 0, but we're going to use the original form, because the original form does factor nicely. Now the reason why I don't like doing this is because it doesn't always factor nicely. But this negative 16t squared plus 32t plus 128 equals 0. We can factor this. This actually does factor very nicely. So let's start off by dividing by negative 16. So we get t squared minus 2t minus 8 equals 0. So this actually factors, like I said, very nicely. T minus 4, t plus 2. This would give you t equals -2, which we can't have negative time. This one would give us t equals 4. So if it does factor nicely, right, if it does factor nicely, that's a much easier way of doing it. But that doesn't always happen. That's why I like to do it the other way, because the other way will work regardless. Whether it factors nicely or not, the other way will work. But either way, we got to get down to this time equals 4. After 4 seconds, plug that in for t in our velocity function and solve. Okay. Now I will mention that this, on the actual test, I made this a bonus question. So you're not actually going to have to do this problem. After you finish the whole test, if you have time left over, you go back and do it if you have time. And if not, it's not going to hurt to leave it blank because it's a bonus question, okay? So you don't really actually have to do that problem. All right. Next up, the last two problems are finding our x and y intercepts, making a sign chart, and then graphing everything. So we're going to start this off by finding our x-intercepts. Okay, so this one is already factored for us, so we don't need to do our initial part of factoring like we have to do with number 9. So the x-intercepts here are 2, 0. Okay, we want to find out what makes each of these 0. Okay, so this is a 2, 0. This one is a -1, 0. This one is a 4, 0. And the last one is a -3, 0. Those are your x-intercepts. The y-intercept, again, there is only one y-intercept, and it's basically what you get when you take all of these factors up top here and you plug in 0. So if I plug 0 in for x, I get -2 times 1, which is -2, times -4, which is 8, times 3, which is 24. So the y-intercept here is 0, 24. Multiply those numbers, not your x-intercepts. Okay, so we end up with 0, 24. All right, so now my sign chart. Let's go into my sign chart here. We have x. We're going to have some values. I'll just stretch it over here. Start with a blank space. Smallest number is -3. That's going to give me a 0. Leave a space. Then I got a -1, which will give me a 0 again. Leave a space. Then I got a 2, which will give me 0. Leave a space. Then I got a 4, which will also give me 0. And I need some number after it. So let's pick some numbers here. Smaller than -3, let's go -5. In between here, I'm going to say -2, 0 in there. I'm going to say a 3 in here, and I'm going to go with 10. All right, come up to your factored form. So plug in -5. I get a negative. -5 plus 1 is negative. -5 minus 4 is negative. And -5 plus 3 is also negative. If I multiply 4 negatives, I get a positive. All right, now -2. -2 minus 2 is negative. -2 plus 1 is negative. -2 minus 4 is negative. And -2 plus 3 is positive. 3 negatives makes a negative. 0. Well, I already know 0 is going to give me 24, so that's positive. 3. 3 minus 2 is positive. 3 plus 1 is positive. 3 minus 4 is negative. 1 negative means negative. And again, we only have to check the negatives here. Once they become positive, they will not be negative again. So 10 minus 4 is positive. You can check the other ones if you want, but you don't need to. So there's your final table. Let's put it all on the graph here. I got a point at 24. Got one at -3, so 1, 2, 3. I'll put an extra one there. 1, 2, 3, 4, 5. Let's get our points on here. So we got +2, -1, -3, +4, 1, 2, 3, 4. There we go. 24. All right, everything less than -3, everything less than -3 was a positive, so this one will go up. Everything between -3 and -2 was negative, so this will go below. From our table, we know that this has to go up, but we also know that this has to connect with this and this. So whether you look at the table or just know they have to be connected, that's either way you're going to get the same thing. Everything between 2 and 4 is 3, which is negative, so it's going to go down here. Everything bigger than 4 was positive, so that will go up. So there is your final graph for number 8. Last one, number 9. This one we got a little bit more work to do because we do need to do our synthetic division first. So remember, we're going to take this number, opposite sign, so positive 1, put it on my shelf. And then take all our coefficients here. So negative 1, 4, 1, negative 16, and 12. Remember that our synthetic division should provide us with a 0 for the remainder because I'm telling you that this is a factor. So the remainder has to be 0. All right, here we go. Let's do this. Negative 1, bring that down. Negative 1 times 1 is negative 1. Then we add our columns. We have a 4 minus 1 is 3. 3 times 1 is 3. Add them up. 1 plus 3 is 4. 4 times 1 is 4. Negative 16 plus 4 is a negative 12. And negative 12 times 1 is, you guessed it, negative 12. They cancel. We get 0. We're done. Well, we're done with the synthetic division part. We still got to do the rest of it. Now remember, this tells us that we have a polynomial. It's a negative 1, but it's a negative 1 times 1 power less than this, so x to the third. So that's what we're going to start with, negative 1, x to the third. And then we have 3, we're going to drop down by 1, so x squared plus 4x minus 12. That's what that means, okay? All this synthetic division is the shorthand way of dividing, so we need to transfer this back into a polynomial, and that's what that means. But again, we need to remember that x minus 1 is still part of this problem. We divided it out, but it is still part of our problem, so make sure you have that there at the end. All right, now we got to factor some more. For this one here, I'm actually going to take a negative out first. So we have x cubed minus 3x squared, excuse me, minus 4x plus 12. Okay, you don't have to do that, but sometimes it does help with our factoring. So like I said, this problem will be a factor by grouping. So I'm going to group these together and do my factoring from there. So I got my negative out front. Out of the first two here, I can take out an x squared, and I'm left with x minus 3. Looking at this second part, again, no way I'm getting an x squared, so I have to end up with an x minus 3. That tells me I'm taking out a negative 4. And then we're left with x minus 1. These both have an x minus 3, so we'll take that out. So again, I have my negative out front, take out an x minus 3. I'm left with x squared minus 4, x minus 1. This is not a linear factor, so we need to take that down. That's our last step. X minus 3, x plus 2, x minus 2, and an x minus 1. So, seems like a lot, right? Like there's just a lot of stuff happening here. We're starting with synthetic division. Took out a negative, factor by grouping, difference of two squares gets us all the way down to our linear factors here. Okay, so if you need to pause and rewind that, go ahead and do that just to make sure you understand all those pieces. Because now we're going to take this last part. Okay, once we have it like this, it's no different than number 8. But it's going to take a few minutes to get it to that point. So, all right, so let's go ahead and write all of our x, y intercepts and all that other good stuff. So x intercepts, again, what makes each of these 0? So this is a 3, 0. This one's a negative 2, 0. This one's a positive 2, 0. And this one's a 1, 0. The y-intercept, I'm actually going to go back to the original. Anytime you have this in the original form, your y-intercept will always be what you get when you plug in 0. So like this is 0, this is 0, this is 0, this is 0. This one doesn't have an x, so we're just left with 12. So my y-intercept here will be 0, 12. Then I'm going to go to my table. So here's my table. Blank space. Smallest is a -2. Blank space. Next one is 1. Blank space. Next one is 2. Blank space. Last one is 3. Blank space. All right, so all of these gave me a 0, so I'll just fill in zeros, or you can cross them out or whatever. We're not actually doing anything with them. So we need some numbers. I need a number less than -2. Let's go -3. Between -2 and 1, I'm going to use 0 because I already know it gave me a 12, so I know that's positive. Between 1 and 2, got to use a decimal. I'm going to use 1.5. Between 2 and 3, again, I got to use another decimal. I'm going to use 2.5. And a number bigger than 3, I'm just going to say 5. Now, two things about this problem. First of all, same thing as before, we plug them into each of these parts. But another thing is we are starting with a negative out front here, so there will always be a negative there to begin with. And I know some of you had this mixed up. Just make sure that you are aware of that. There's a negative out front, so it needs to be there. So now let's plug these in. So -3 minus 3 is negative. -3 plus 2 is negative. -3 minus 2 is negative. And -3 minus 1 is a negative. So we count them up. 1, 2, 3, 4, 5 negatives means negative. And we look at 1.5. Again, this is always negative. 1.5 minus 3 is negative. 1.5 plus 2 is positive. 1.5 minus 2 is negative. And the last one, 1.5 minus 1 is positive. So 1, 2, 3 negatives means negative. 2.5 again, I'm just going to look at my negatives. This one is always negative. 2.5 minus 3 is negative. 2.5 minus 2 is positive. 2 negatives means positive. And the last thing, 5, well, this one's always negative. 5 minus 3 is positive. 1 negative means negative. Now let's put it all on the graph. I have 0, 12, and then I got a 1, a 2, a 3. Throw an extra one there. And I got a -1, -2, -3. So I have points at 3, 0, 1, 2, 3, -2, 0, 2, 0, and 1, 0. And then I got this guy up here at 0, 12. So going to our table, everything less than -2 is a negative. So this is negative, it's going down. Between -2 and 1, it was positive, but again, this had to connect with this and this. So we knew that that had to be a positive there, and it had to go up. Between -1 and 2 was a negative, so this will go below the x-axis. Between 2 and 3 was a positive, so this will go above the x-axis. And everything after 3 was a negative, so this will go down like that. So it kind of looks like a capital M. Okay? So again, you're going to have problems just like this on your test. The only thing that will be different is number 7, part E. That the last part of that problem will be a bonus, so it is not something that you are required to do for your test. Okay? But everything else is stuff that you're going to need to be able to do. Rewind the video, watch it again, email me if you have questions, or let me know if there's anything that you have questions on. But like I said, you're given the formulas, same type of problems. You just need to know how to use those formulas in each of the problems, okay? So let me know if you have any questions.